All right, hey everybody, welcome back. We're looking at functions part 2 today. After a very successful launch of functions part 1, it seemed like that went very well and everyone was understanding everything. It's gonna get harder today though. All right, so we're starting off with an old slide because I want us to keep in mind every time we go through this, I want to keep pointing this out, that a function is a relationship between two sets of data, right? So that's the key kind of part of a function. That's the whole point of making a function, is to model that relationship between two sets of data. Okay, so onward to some new stuff. A function rule is what we're learning about here, and it maps all of the numbers in the domain to the range. So for instance, the function below would map any number to that number multiplied by 2, right? So we have f of x equals 2 times x. So whatever the domain is, it gets multiplied by 2, and then that's the range value. You would read this, function of x equals 2 times x. Note that the f and the x are not being multiplied together. That's a separate thing. It's called function notation. And you would read it, function of x equals 2 times x. Okay, so here we have this function, f of x equals 2x. And you can see some domain and range values that I've computed. And you can take any number, right? Any number could get multiplied by 2. So I've just chosen a random assortment of numbers. We have a decimal, we have a -1, we threw 0 in there, right? And you can see what the range is after they got multiplied by 2. So go ahead and pause the video, analyze this a little, make sure you're understanding kind of how the function rule works. Then let's continue on. Now, the domain and range can contain a set of infinite numbers. So you could have infinite numbers in the domain, right? Any number you want could get multiplied by 2, and then that would give you the entire set of real numbers for the range, right? So I put this on here to illustrate that the domain and range could be the set of real numbers, which would give you every possible number under the sun, every possible number in the laws of physics. Okay, so there we go. Here we go. We're kind of illustrating that point a little bit here, where I just chose another completely random number. I chose x to be -112.49, and you could see what the range value is. It's -224.98, right? And then I wrote up here, next up, remap -112.491, and then -112.492, then 493, 494, right? And we sit here all day and all night and all day and every day for the rest of our life, just multiplying numbers by 2, and we'll never run out. Okay, so here we go, a little bit of time for you to practice. You're going to write your own function rule, and you're going to write it right here. Now I'm encouraging you to use an operation other than multiplication. We looked at that one, multiplying by 2, so maybe choose addition, subtraction, multiplication, division. Write a rule right here, and then give some domain and range values that illustrate the correct mapping. Okay, here's another one. The catch this time is that you have to use 2 operations. So you have to pick multiplication and addition, subtraction and multiplication, whatever 2 you want. If you want to get crazy, you can start throwing in some exponents, some square roots, whatever 2 operations you want to have. Okay, and here we go. So placeholder page, work on some of those IXL problems, and then we come to the main event, which is, I'm really excited about this one, and this is going to allow us to start modeling with functions and see a function being used to model something in reality. All right, and now this isn't maybe the most useful thing, but it's a good way to illustrate something using numbers. All right, so what we have is a candle that's 8 inches long, right? So when you first light it up, it's 8 inches long, and then it burns for 1 hour, and it's ½ an inch shorter, right? So every hour the candle burns down ½ an inch. So hour 1, it's 7.5 inches. Hour 2, it's 7 inches. Hour 3, it's 6.5 inches, and so on and so on and so on until the candle disappears and burns itself out. All right, so you can see the picture illustrating it right here. Hopefully that's understandable enough. Okay, now this is a page of directions that shows you what to do on the next page. So you can refer to this. I'm also going to show you on the next page what to do. So here is a puzzle that you're going to try to solve by dragging all of these numbers into their proper place. And the way you do that, for instance, I know we're, oops, sorry, okay, I keep forgetting that you have to escape. You can't be in presenter view. You have to be in editor view. So I know domain goes over here because the arrow is pointing this way, right? So I know domain's over here, range is over here. So I'm going to click on the domain and I'm going to drag this to its proper place. Okay, now how did I do that? Let me Control Z. First thing you do, step one, is you click on it. Okay. Now you're going to go to the edge and you're going to hover until you see that 4-pronged arrow piece, and then you're going to click on that and you can drag it around wherever you want it to go. So you can drag it down here, you could drag it over to its proper place, you could drag it up here, right? Wherever you want it to go. Now avoid the corner. If you avoid the corner, you'll just increase the size of that. And if you make a mistake and you need to undo something, that's fine. You can just hit Control or Command Z and undo whatever you just did, right? So you move it up here, you hit Control Z, you're back where you started. You can also use this button right here, right? You can use backward and forward there as well. Okay, so again, you click on what you want to move. You look at the, for the movement arrows, and then you drag it where you want it to go, right? Maybe you want it there, maybe you want it over here. Wherever you want it to go, you put it there, and you can solve the puzzle. Okay, now here's some questions. Let's go back into presentation mode. Here's some questions about the candle and the burn time. All right, and then here you're going to try to write a function rule for the candle. This is probably going to be tough, but I believe in you. You can do it. If you can't, even if you can't figure it out, make a guess. Okay, make a guess, even if you can't figure it out. And then you can give some logical domain and range values for the function. You know, keeping in mind that a candle could not be negative inches long, right? A candle can't get shorter than 0, and a candle can't burn for negative hours, right? You can't unburn a candle. Okay. And then think of a situation that could be modeled by a function, then you create a function for it, right? So we started with some easier stuff last week. Now we're moving into some harder, more cognitively demanding tasks here. So good luck, have fun, and I will see you soon.